Today, we're diving deep under the hood of one of the most popular VPN protocols out there, OpenVPN. We're going to skip the high-level stuff and get right into the technical nitty-gritty to see what really makes it work. Have you ever really stopped to wonder what's happening when you click Connect on your VPN? I don't just mean the general idea. I mean, what does the raw data look like? What's the structure? What's that digital handshake that kicks the whole thing off? Well, stick around because that's exactly what we're going to unpack. All right, so before we start dissecting individual data packets, let's just make sure we're all on the same page. What is OpenVPN, really? At its core, OpenVPN is an open-source tool that creates a secure tunnel for your internet traffic. Now, the magic ingredient here is its use of SSL/TLS. If that sounds familiar, it should. It's the exact same encryption technology that keeps your online banking and shopping safe. You know, the little padlock you see in your browser's address bar? By building on that proven, trusted standard, OpenVPN started on incredibly solid ground. So why did OpenVPN get so popular with network admins and developers? I mean, what makes it such a go-to solution? Well, it all comes down to its core design and just how flexible it is. Let's just run through the highlights. First, it encrypts with TLS. We just covered that. It can also run over either UDP, which is great for speed, or TCP, which is better for reliability. That's a huge choice to have. And because it's completely open source, an entire global community is constantly checking its code for any weaknesses. Plus, it's been around since 2002. That means it is seriously mature and battle-tested. And this right here, this is probably its biggest advantage over older protocols like IPsec. See, OpenVPN was built to work with the internet we actually use. It doesn't need any special proprietary hardware. It just tunnels its traffic over standard web ports, making it look a lot like any other secure website. That simple idea was an absolute game changer. Okay, so when you're setting up an OpenVPN connection, you hit your first major fork in the road. You have to choose between two very different operating modes, and this choice fundamentally changes how your virtual network is going to behave. So on one side, you have routing mode. This works at layer 3, the network layer, and it tunnels your IP packets. Think of it like creating a totally separate private highway just for your data. It's clean, it's super efficient, and it scales up for tons of users really, really well. Then you have bridging mode. This operates a layer deeper, at layer 2, tunneling raw Ethernet frames. This basically stretches a virtual Ethernet cable across the internet, making it seem like your remote computer is physically plugged into the office network. It's amazing for some very specific uses, but man, it can get messy and inefficient fast. So the bottom line, routing is for scaling up, bridging is for making things look local. Okay, our tunnel is built, we've picked a mode, but how do we make sure only the right people get in? That brings us to the most critical part, the digital handshake, or authentication. This is the million-dollar question in network security, right? How does the server know the client is legit, and how does the client know it can trust the server? Well, OpenVPN gives you two main ways to solve this puzzle. The first and simplest option is a pre-shared key, and it's exactly what it sounds like. It's just one single secret password that both the client and the server already know. It's super straightforward, but you can probably spot the issues, right? You have to get that key to the other person securely before you can even connect. And if that key ever leaks, your whole setup is compromised. Now, the much more secure and common method is using certificates. In this setup, both the server and the client have their own digital certificate, which is kind of like a digital passport that proves their identity. They show each other these passports to build trust, and then they negotiate a brand new temporary session key just for that conversation. And here's the best part, that session key gets renewed all the time. So even if an attacker could somehow crack one, the damage would be incredibly limited. All right, you ready for this? We're going in. We've talked about tunnels, modes, and keys. Now let's rip open a single OpenVPN packet and see what it actually looks like as it flies across the internet. And right away, here's something that might surprise you. While all your data, the actual payload of the packet, is locked down tight with encryption, the OpenVPN header itself is not. It's sent in plain text. Now this means a network can see that you're using OpenVPN, but it has absolutely zero idea what's inside that packet. So what's actually in this tiny, unencrypted header? It's just 24 bits long, broken into 3 little pieces. First, you've got 16 bits that just say how big the whole packet is. Then, there's a 5-bit field called the opcode. And finally, a little 3-bit key ID. Each one has a super important job. Let's look at that opcode. You can think of it as a label on the packet that says what it's for. It tells the other end whether this is a control packet, stuff for setting up or tearing down the connection, or if it's a data packet, which is the stuff you actually care about. It's basically the traffic cop for the entire tunnel. And that last little 3-bit piece, the key ID, this is the secret to that awesome security we talked about earlier. Remember how the session keys are always being renewed? Well, this tiny ID is what tells OpenVPN exactly which key to use for this specific packet. It's what makes that seamless, on-the-fly key rotation possible, and that's a cornerstone of its security. So when you step back, you see the brilliance of OpenVPN is how it cleverly used technologies that were already proven. From its different modes to that super efficient packet header, it was just built for the real world. Its use of open standards really did change the game for secure networking. But, technology never stops. As we push for even more speed and simpler cryptography, what does that next evolution even look like? Is it just a better OpenVPN, or is it something completely different? That's the next chapter we're all waiting to see.